All right, can anyone tell me what a phase is? What is a phase? It's a definition which, it's a term that is used very often, but we generally do not understand it very clearly.
Phase as in like solid, liquid, and gas, like the phases in between.
So these are, yeah, good. So you have solid and liquid and gas. These are the states of matter, right? No need to go through this, we already know it. If you go through the videos, you will also find out a little bit more about extrinsic and intrinsic properties and things like that. But more often in geology in general, this concept of phase that comes up repeatedly. It does not necessarily mean either of these things, but it is obviously coming from this part. So just imagine a system. In that system, there could be any of these things present. Okay? In that system, there will be a clear boundary between certain things. So I also use this example in the video, and that's why I'm like not trying to use this example. But if you have a pitcher of water with ice in it, so the physically distinguishable things that you can see are actually physically separated from each other. There's a clear boundary between certain things, that becomes a phase. If there is a clear boundary between two things, that becomes a phase. A clear boundary also means a stark difference in properties. Okay? So if you have ice, you can clearly say that the ice is a different phase and the water is a different phase because you can physically see that being separated. Okay? Now another example would be, so that would be a homogeneous properties kind of equates to one phase. So like if you have one phase, it will have all the same properties, kind of like that. It might get complicated in future, but the general idea is very simple. Don't be like alarmed when you see the term phase. It's just a homogeneous set of properties together where you cannot differentiate. There is no stark boundary, that's a phase. Same properties without boundaries is not a phase. But sometimes, okay, for example, liquid water, if it has salt dissolved in it, so there are no two phases in there, right? It's all the same. You cannot physically differentiate. A lemonade, it's all the same phase. So there are different components, but it's all one phase. The components and the phases will be different. So components would be water, salt. The salt might be ionized, Na+, Cl-. There could be carbon dioxide in it if it's a carbonated beverage, right? There could be sugar in it. So all these things are the components, but the phase is one. There's only one phase in that, right? It's simple, it's not complicated, it's simple. Let's just trying to make it clear before we get into the more phase diagrams and stuff like that, right? Okay. Air might not have the same, right, so when you have the lemonade, so if the lemonade has different taste on the top and the bottom, probably it's not the same phase. If you just shake it and then keep it, after a while, the two phases will separate. That will happen in oil and water. So an oil and water system will be two phase because at one point I did this, but if you let it settle, it will differentiate. But lemonade should not, a good lemonade should not do that. Like if you buy a bottle and it separates out, you're like, this is not what I bought, right? So there are two different phases, two different properties will separate out. Atmosphere, although the composition of this room might just be slightly different than the atmosphere in your office or in your home or at the top of, I don't know, of this building. It might just slightly be different, but that change is so little and so gradual that it all can be clubbed into one phase. Although the compositions are different, just slightly, but there's no sharp boundary, right? So if God forbid, some poisonous gas comes out in here, at that particular point, this room will be different phase than the other room because the composition will be so starkly different. Or if I take potassium permanganate, a salt, colored salt, and put it here, so that at that particular time, that is a very different phase. But given enough time, again, things when they become kind of uniform and kind of gradual changes, then it also becomes a one phase, okay? That's there. Now, what do you call this process?
Melting.
Yes, it's easy, right? So what is happening at the molecular level when you are melting? So you would see that solids are represented something like this. And liquids are kind of represented. It's a very simplistic diagram. There are many errors in it, I know. But kind of simplistically, what happened here? The process is melting, but how do you melt stuff?
Increase in energy, higher temperature,
Yeah.
stability.
Right. Courtney was telling something?
I said you heat it for like ice and stuff. It is.
Right. You increase the energy and they break apart and they become this. But if you have, okay, what's the reverse thing called?
Solidification.
Sorry?
Solidification.
It's a kind of solidification, but this is a more common term.
Freezing.
Freezing, yes.
Evaporation.
Right? Evaporation. Everyone agrees? Who doesn't agree? Or who wants to add on to this? There is another process. Sorry?
Precipitation.
No. Precipitation means you have a solution. So these are all very confusing terms. Like precipitation means you're forming a precipitate. And generally for chemists, that means you have a solution. And out of that solution, you are forming a solid. You're precipitating a solid. So that's precipitation. But who can add on to this? Because
It's condensation.
so condensation, let's dial down to the term condensation. There's a term called dense in it, right? So condensation, making it dense. So you are there, but you are referring to this. So when gas goes to liquid, it is becoming more dense. So that is condensation. And when gas goes to solid directly, that is also a form of condensation, but that has a special term.
Is it vaporization? Vaporizing?
So there is another term that is coming up, vaporization. Okay, let's just hold on to that for a second. It's important, we will discuss. But what is gas to solid? Chinu, you wanna? Boiling?
Yeah.
Let's hold on to that term. When I say this term, everyone will be like, oh yeah, sublimation, right? So when solids sometimes bypass that liquid phase, and when solids directly go to gas, or gas even comes back, that is like sublimation process. But gas to solid and gas to liquid are both condensation. Can you give an example of a solid that sublimes? It's a nice word. Anything? Anything that sublimes. Just take the solid and directly convert to.
Is that ice called?
Yes.
There you go.
What is dry ice now?
CO2? Frozen CO2?
Yes.
Yeah.
So solid CO2, when you heat it at room, now the pressure is important. Let's talk about everything that happening at room pressure, room temperature pressure. So if you take solid CO2, it can directly convert to gaseous CO2 without going into liquid CO2. So that is sublimation. There's also iodine or iodine and camphor. Have you heard about camphor? It's used, naphthalene balls that you use for keeping the clothes like not smelling bad and things like that. All these things are examples of sublimation. But we came across two very important terms, and these are both the same thing. Vaporization and boiling are the same thing. But if we break this term, we get the term vapor. So vaporization should mean that either something is converting to vapor or vapor is involved in some way, right? So vaporization is just liquid to gas or boiling. These are interchangeable. Let's use the fancy word, vaporization, just to impress people outside this class, right? What is the difference between evaporation and vaporization? Because in both, vapor is there. But these two are not the same thing. These are two different things. Both are leading from liquid to gas, but it's not the same thing. Now, if you have your bottle open up and place it in the sun, what will happen? Like, not the term, actually what is going to happen?
The water is going to dry up. It's going to turn into gas.
Yes. So it could be either evaporation or vaporization, right?
I thought it was evaporation, so I'm not sure. I guess vaporization technically because of the...
No. Don't doubt yourself. Hold on to your beliefs because you're correct. If you just place that thing outside, it is going from liquid to gas, but it is not vaporization, it is evaporation. It is evaporation, it's not vaporization. Because evaporation is boiling. Did you boil it? You did not. Now let's go to boiling. When you actually have a pan of water and you're boiling it, what do?
Excite the molecules by it.
You give them heat, right? You put the pan on the stove, turn on the heat. You don't wait there watching, which you might do for evaporation. If you spill water and come an hour later, at least it will reduce in quantity. That is evaporation and not vaporization. So what's the difference? There is a difference, right?
One involves the sun,
One involves the sun,
and the other one you're applying heat to it.
right? But the sun is also applying heat.
One's getting it to its boiling point. I don't know.
You're right. One is getting to its boiling point. So we are coming up with terms now. Boiling point. Ooh. What is boiling point?
The point where.
What point? What the point? The place point?
It's when oh my God, it's when you're heating something and it can no longer Like that's the point where it starts changing phases, kind of.
Phase change. But what point? What point are you talking about?
Critical.
It's a critical point, but
Temperature, I guess.
it's the temperature. Is that specific temperature at which liquid is changing to gas? I don't know if, can you see this without, should I remove this? I don't know. Are you guys able to see this? Okay. It is that temperature at which suddenly liquid is converting to gas. It is happening at a very particular temperature. So one thing that is happening, the difference between evaporation and vaporization or boiling is this happens at a fixed temperature. Now, if the temperature outside, and I think in degrees because I'm from degrees Celsius because I'm from India, but if the temperature outside is 100 degree Fahrenheit versus 70 degree Fahrenheit, in which case water is going to evaporate?
From the sun in general, or like for vaporization?
Now, tell me one thing, which is going to happen at 100 degrees? Evaporation or vaporization?
Evaporation.
Why? Why did you're right, but why?
The temperature is probably not high enough for it to be.
Yes, because we know that the boiling point of pure liquid water at normal pressure conditions is 100 degrees Celsius, right? Or 232 Fahrenheit, right? That's not the temperature outside. It's still pure water. It's normal atmospheric conditions. So that is not evaporation or boiling. That is not vaporization or boiling. That has to be evaporation. So at what temperature evaporation is happening? I give you two temperatures, 70 and 100. At what temperature evaporation is happening? Both of them. Which of them more evaporation is happening? 100. So increasing the temperature increases evaporation. But this is happening at a fixed temperature. And can you take a guess about like what temperature that would be? Do you know like an upper bound to that? The boiling point would be the upper bound, because when you are going from 170 Fahrenheit to 100 Fahrenheit to 200 Fahrenheit, till you hit that boiling point, there is some evaporation is happening. But vaporization starts at that point, at that temperature. Below that, you will have evaporation, and with increasing temperature, you will have more and more evaporation. Now, why? Like now, let's understand what's happening when you're trying. So, going from solid to liquid, we increased the temperature, right? Somehow the temperature was increased. The energy of the individual molecules were increased. They started to vibrate more and more. There was more energy. And at some particular point, this transition happened. Now let's go through this process. So you have liquid, you are giving heat to it. Heat in, okay? Now, forget about all this. Let's assume, let's imagine a scenario in which you are getting a salary. a fixed amount of salary. Now that salary, I'm making it very simplistic, that salary can go for two things. That can increase your bank balance, or that can go to buy food, okay? Or buying a house or whatever, like just buying stuff. Both of these things are important, but sometimes certain things takes precedence, okay? Now, I am providing the heat in, so this heat in, assume that this is your salary. Now with the salary, this liquid can do two things. What are the two things it can do? Lauren? Just simple. What can it do? When you provide heat to something, what happens to that thing?
The energy increases.
Yes, so temperature increases, right? So the temperature can increase. One thing is the temperature can increase, but what is in here? Is it liquid or gas? What's in this container? It is still a liquid, right? Agreed? It's still a liquid. So if you start this at room temperature and start providing heat, it starts to heat up, but there is no change in the phase. There is no changing, it's still liquid. Now, but it can also do a phase change. This is a major step. It does not happen regularly. So, from now onwards I will talk in degrees Celsius because I'm more like used to that. So, for example, if you have, let's assume this is the temperature in degrees Celsius, and this is the heat that I'm giving. Okay, can you see this? Or I draw here. Tosin, can you see this? This is temperature in degrees Celsius, and this is the heat. So when you go from left hand side to the right hand side, you're giving more heat, so increasing the heat. And when you are on the bottom and going up, that means your temperature is increasing. Okay? Let's assume you have ice. Let's start with ice. You have ice at minus 20 degrees Celsius, minus 40 degrees Celsius. And minus 40 degrees Celsius is the same as minus 40 degrees Fahrenheit. Okay? So you have, say you have minus 40 degrees Celsius ice. Okay? Let's assume you are here. You have ice. What happens when you give heat? At minus 40 degrees Celsius. It will increase its temperature. Very simple, like the liquid water was doing. It will increase its temperature. And remember, we are talking about pure H2O, and we are talking about 1 atm, like normal pressures. This will become important. So when you give more heat, the more temperature it rises. Something like this. Okay? So it is still ice. This is still ice. But at some point, which is 0 degrees Celsius, things will be different. In here, this ice will start changing to become water. It's still at 0 degree. You're giving heat. Please do not stop giving heat. Because if you stop giving heat, nothing is going to happen, like it'll stay there. You're providing heat, but you're getting a salary, but your bank balance is not increasing because you're buying the food. You're giving heat, your temperature is not rising because you're changing from here to here. At that temperature, things are breaking apart. It is not just increasing its energy, it is breaking apart. So this to this happens at a fixed temperature, at a very special temperature, which is called the melting point. So at a melting point, only the phase is going to change. The temperature is not going to change. But at this you also have ice. So at 0 degrees Celsius, you have both ice and water. So any water, if you have a glass of water which has ice in it and it is equilibrated, give it enough time, not just immediately, give it some time. If the liquid water and ice exist together, put a thermometer into it, it will read 0 degrees Celsius. It has to. There is no way out. It has to read. And at 0 degrees Celsius, both liquid water and ice are stable. Okay? Now, after all these things have changed to this, and phase is a very macromolecular, like it is not, a phase cannot be identified by a molecule. It is always through connections, like where are the other things it can be explained. So at this point, after this, it is also going to increase. So even after 0 degrees Celsius, even after all the ice, it will be more ice and less ice, something like this. I'm just trying to show that the ice is decreasing and the water is increasing, something like this. At this point, there will be no ice and only water. At that point in which all the ice has been converted to liquid water, if you're still continuing to give it heat, what will happen? Huh?
Evaporates.
It will increase its temperature. Let's hold on to that evaporation because that's tricky. Okay? We'll talk about that. It increases, I don't think there is any doubt to that, it will increase up to 100 degrees Celsius. And what will happen now? Then we'll again have a phase change in which we get steam, vapor, right? At this, when all the vapor has changed, again, things will happen. I have a video on this. It's much more explained. If the things are not making sense here, go to the video. It'll be fine. It's not a very tricky concept. It's just the phase change. I just wanted to stress upon the fact that phase change is important because it happens at a very particular time, point, a very particular temperature. Okay, which is like this 100 degrees, and then you have superheated steam. In here it is supercooled ice, and water is water, right? Water can be at a swath of temperatures, right? Okay, so this is the phase change. Now, the heat amount. So there is this amount of heat, right, that we supplied in here. This amount of heat is called the latent heat of melting. So the amount of heat you provided to the ice for changing from solid to liquid is the latent heat of melting. The opposite is true when you want to freeze something. You need to take out the energy, right? You are giving the energy, increasing the energy of the system. Now you have to, if you want to cool it, you have to take out the energy somehow, right? So if you take out the energy, that is also latent heat, but it's a latent heat of freezing. You are taking it out and taking it and bringing it in. So this in and out we'll see in energetics. Like you have heard about exothermic process, endothermic process, things like that. So endo means in, exo means out. So exothermic process in which heat is released, right? In this case also, so freezing is exothermic because it's going from liquid to solid, and in doing that it has to release heat, and that is an exothermic process. Okay? All right. So this is latent heat, this is also latent heat, this is latent heat of vaporization. Now, what's the difference between evaporation